Okay, now we've seen the animation on cloud computing, we've got to ask the question, why have cloud computing in the first place? Historically, companies have used their own in-house infrastructure. This can be expensive to maintain, can go out of date very quickly. Any planning for capacity requirements can leave you over or undersubscribed. So you've got the option of outsourcing your requirements to the cloud. This removes a burden and also reduces the total cost of ownership. There are two elements of the cloud, abstraction and virtualization. With abstraction, your applications, data and physical equipment are stored in remote, unknown locations. But it is most likely that these resources will be provisioned from a centralized, virtualized infrastructure.
Will cloud computing be the next utility after electric, gas and water? The answer to that is yes. In the next few years, cloud computing will become the next essential utility.
What makes a cloud special is its essential features, such as the following. Elasticity gives the cloud the ability to expand or shrink on users' demand. On the other hand, broad network access is to have the cloud universal, so that the data can be accessed via all platforms from anywhere at any time. Resource pooling is the ability to share IT resources easily. Measured services means everything that you use in the cloud is measured, just like your electricity. This gives the cloud its most important feature and enables the pay-as-you-go model.
Cloud computing systems share common features such as being homogeneous. This means that the systems consist of equipment or technology which are normally provided by one vendor. This can be a double-edged sword, whereby a vendor will lock you into their product, but compatibility issues will be resolved. This leads to flexible capacity planning, which means that a company doesn't have to have the infrastructure within their premises for the eventuality that may never occur. This also ties in with the total cost of ownership that can be reduced for the business because of the efficiency the cloud provides. Cloud computing systems also provide advanced security systems that can be considered state-of-the-art because they are always up to date and they are always using new technologies which provide better features and functionality.
Service models. We have researched several cloud service models and we feel the NIST, National Institution of Service and Technology model, represent the best interpretation of cloud. Now we will look at the 4 deployment methods of cloud.
Okay, the first of the deployment models is the public cloud or the external cloud. This describes cloud computing in the traditional mainstream sense. Public clouds are often open to the general public or a large industry group and are owned and managed by a cloud service provider. Private clouds or internal clouds have been described as offerings that emulate cloud computing on private networks. Private clouds are operated solely for one organisation. They can be managed by the organisation itself or by a third party, and they can exist on or off premises. They are being criticised on the basis that users still have to buy, build and manage them, and as such do not benefit from the lower upfront capital costs and less hands-on management.
Third deployment model is hybrid cloud, combining 2 or more private and public cloud by technology that enables the data and application portability. The goal of the hybrid cloud is that you run out the capacity in private cloud. You can quickly reach out to the public cloud for additional resources and continue to operate your business. The last one is community cloud. Cloud infrastructure is provisioned for exclusive use by a specific community of consumers from organizations that have shared concern like mission, security, requirement, policy and compliances consideration. It may be owned, managed and operated by one or more of the organization in community, a third party or some combination of them, and it may exist or on off premises.
As we can see from this slide, if businesses have their own in-house services, they have the responsibility for managing all parts of their infrastructure, from their applications through to their networks. When using the cloud, they have access to any of the 3 as-a-service models. These are software as a service, platform as a service and infrastructure as a service. If we look at the 3 service models, we can see there is a separation of responsibilities between the 3 services. When using the infrastructure as a service model, the subscriber has to manage applications, data, runtime, middleware and the operating systems. This is the most flexible of the 3 models. Examples of this model are Amazon AWS, Savvy Symphony and Terramark vCloud. The platform as a service gives users access to just the upper two services, applications and data. Examples of this model are Salesforce.com and Google Apps. Last but not least, software as a service model. All the services are managed by the service providers, which allows the user to access services, applications and any other cloud-based service without anything except the browser they use on their PC. Examples of this include Salesforce.com and Google Apps.
The value chain model is used by a business to visualize these information systems and how they interconnect. Cloud computing can affect the entire model or a specific part of the model. We believe that it varies on a business-to-business basis. Businesses choose to use cloud computing because of its effects on its information systems and the benefits it can provide.
Resource sharing enables the usage of the many IT infrastructures when required. This, in its most basic term, means that if you need more CPU power or RAM to manage a heavy task, then the cloud would utilize maximum resources to get the task done efficiently. Rapid deployment. Now that we know how resource sharing works and manages workload distribution, this enables administrators to quickly deploy anything onto the cloud. This makes the business more agile and more responsive. Rapid scalability. Today, you might have an application deployed to the cloud worth 500 GB. Tomorrow, your application might increase to 1 terabyte. The cloud is designed to quickly allocate more or less storage based on your needs. The ease of access, because the user-end applications are web-based, your access to the cloud computing services does not depend on the computer you're using. All you need is a web browser.
Because of this, payment models such as pay-as-you-go are used, which reduces the expenditure for the business and is overall more efficient. This means that SMBs, small and medium businesses, are in a position to compete with larger businesses. Because of the reduced total cost of ownership and operational expenditure, businesses can spend less in staffing as well as making savings indirectly by using less in electricity, etc. This makes the infrastructure as a service model appealing to a business because it can potentially save massive amounts of money and is environmentally friendly. You can also assume that the cloud will be future-proof for a business because they never have to change any of their infrastructure as it is done without them knowing.
Okay, we'll now take a look at Gartner's hype cycle. Hype cycle methodology gives you a view of how technologies evolve over time. It also provides a sound insight into the deployment of technology to meet your business goals.
In this slide, we're going to look at hype cycle stages. There are 5 stages of hype cycle. First, technology trigger. A potential technology breakthrough kicks things off. Second one is peak of inflated expectation. Publicity produces a number of success stories. These are more often than not accompanied by scores of failure. Some companies take action. Third one, trough of disillusionment. This is our make or break time. Interest wanes and as experiment and implementation fail to deliver. Investments continue only if the surviving provider improves their product to the satisfaction of early adopters. Fourth one is slope of enlightenment. In terms of how the technology can benefit the enterprise start to become more widely understood. Second and third generation products appear from technology providers. Last but not the least, plateau of productivity. Mainstream adoption start to take off. Criteria of assessing provider viability are more clearly defined. The technology, broad market applicability and relevance are clearly paying off.
Okay, now that you understand the hype cycle, let's see how cloud computing has evolved over the last 5 years. If we take a look back at 2008, we can see that cloud computing was in the technology trigger phase, and Gartner was predicting it would take between 2 to 5 years to reach the plateau of productivity. Okay, we'll skip forward to 2013 and we can see that cloud computing has descended into the trough of disillusionment. Progress has been made, but Gartner is still predicting it will take 2 to 5 years to reach mainstream acceptance.
The future of cloud. As we notice, most of business and industry is already moving towards cloud. What Gartner predicts, it says this is going to be major shift towards cloud-based system. will begin by the first half of 2015 and reach 3% penetration by 2017.
In terms of disadvantages of cloud computing, we need to take note that it is not fully customizable. Also, on the other hand, it is not a stateless system. For example, you are requesting information from your internet service provider and not the cloud itself. Messages can travel over different routes and reach out of sequence. This can introduce a large performance hit. Many users do not have duplex internet connections, and speed in remote areas can be poor. This limitation can be a major disadvantage of using cloud to such users. Another major disadvantage is the fact that the cloud only has 99.9% uptime. You may be asking, how is that a disadvantage? Well, let's think of this on a big scale. 99.9% means in 1 year you can have 9 hours of downtime. For a big company, for example Amazon, this would mean millions of pounds in damage. When talking about legislation, we need to take note that at this current point we do not have a fully governing body for the cloud, and that makes different countries or even states or cities within a country have different laws to data. On the other hand, your data is and always will be at risk. Why? Well, simply put, you're handing over your data to a provider and hence putting them responsible for your data. But really, are they really responsible for it? Data transmission is directly linked to legislation, and since there is no solid laws yet on how your data decides to travel or where it lands is a big question. Now that you can already witness so many question marks which rotates around legislation, this brings us to another major problem. We are aware of the few disadvantages of the cloud, and assuming you understand the fundamentals of data transmission, we land upon this major problem, and this is called the Wild West computing. What it simply means is that the cloud provider provides you the services and take no responsibility for your data. Hence, you and only you are solely responsible for it. But because of the way the cloud is designed and its complexity, the fact is we really don't know where our data resides at a given point. Should we really be held responsible?